The next feature I'll review here is the passwords feature. What this does is it'll go and scan either the local computer or the mounted drive and search for some different password types. First tab here shows browser passwords, so anything that might be cached by the browser would be found here. Then the Windows login passwords, so your SAM files, for example, that are on a Windows machine would be scanned and find any of those hashes that are found there. And then what you could do is, once you have these passwords gathered like this, here you could save it down to a file of some sort, and then you could generate yourself what's called a rainbow table. Rainbow table is a large listing of potential passwords, and for example you could pick the type. In this case we'll generate a real small table of numeric passwords, see what we can do, let it run, and then it'll calculate these out and then produce a file for you. Then when you have that file, you can take that file and then retrieve passwords with a rainbow table. So you say, okay, take my rainbow table, do some sort of hashing algorithm, compare it against the file that I just generated by finding the login passwords, and then hopefully it will find a match, and the result would be the actual login information that you need. This next button here is system information. This will actually just give you the running system information. So for example, it'll give me my local laptop here. It won't look at the system information found on that D drive. So it might be interesting if you load this tool maybe from a USB drive or something like that onto a laptop that you want to investigate, and then you can run it there and find out some information about that system. Verify and create a hash. What this does is you have a set of files. In our case, for example, we've got these DDs on my disk. I don't know where it's available. Let me take a look here, see if I can find those files, and then what we can do is compare the hash of those files against the file hashes found in the notes section. So for example, I'll pull this file up. I'm saying calculate an MD5 hash. Let that go ahead and run. And the intent of this is to find out if the data was altered in transit at any point. So here you can see that this notes pad, for example, on this sample that I have, gives me the expected hash values for each of the various files. I picked the first one, the chart01 file. It calculated a hash. I'll go ahead and paste in the hash that I found in the notes, and it will compare the two, and you can see by this little green check mark and this note down here, hashes are equal. So that's good news. That means that the file was not altered from the point of taking it off the machine and then transferring it to the investigator. This is going to be necessary to prove in a court of law or something like that somebody didn't tamper with the evidence, and provide everybody a reasonable amount of assurance that the information there is factual. Hash sets. There's a NSRL website, and they create hashes of various applications. They might be malware, they might be some other things, and the idea is that you take this database and you load it here, and then it can do a comparison of the hash values of applications or information that are found on the scan drive, and if there is a match, then it might indicate that that file is in fact a malware or something that needs to be further investigated. Create a signature. The idea is here to sign a piece of data and say, okay, we need to put our signature on it and say, I verify that this is the data that I have investigated, and so you can just kind of find the drive, go in here, select that, and probably do some configurations here. Output type is a signature. It'll be, something of some nature, and it'll just generate one. Compare a signature. The idea is that you put your stamp on this thing, you get back the data, and then you say, okay, I want to compare the signature that I just did with a new signature. Drive prep. I think this one just does a wipe of a drive or something like that. Create a drive image. So say you have some data on a computer and you want to create the DDA images. This is what that will do. Mount drive image, just as we did at the beginning. Just find the drive and mount it so you can read it. Forensic copy is to generate a real strong controlled copy of the data. Install to USB and register and things like that, or more about the application itself. And then exit, of course, is to exit the application. So these last few features I went over pretty quickly. I haven't used them very extensively, but I'm sure online at OSForensics you can get more data and or just try them yourself.